Hi, and thanks for watching this video. Within the next few minutes, I'm going to introduce you to BE.services real-time test framework. After explaining the concept, I will demonstrate how the tool is built and can be used. In modern automation systems, the real-time performance of industrial controllers gains in importance, especially for demanding applications requiring synchronization between axes or between the controllers themselves. Some operating systems provide very good real-time performance out of the box, others via extensions, but there is no guarantee whatsoever that firmware implementation will not influence this performance, which is hard to track down once the issue is noticed. This is the reason why the BE.services real-time test framework was developed as a companion during the development phase of an ICS. Thanks to RTTF, the manufacturer can measure performance of the tasks and the Ethernet communication. The framework allows simulation of different stress conditions, and it's been developed to be as user-friendly as it gets, an automatic executed test environment. The RTTF was developed to test and measure the performance of ICS that are based on the CODESYS technology. CODESYS is a soft PLC solution developed, maintained, and distributed by the company of the same name. While the technology was developed as an IEC 61131-3 programming environment, it's grown to a complete automation suite, providing I/O control but also motion control for single and multi-axe applications, as well as robotics. The IDE provides editors for HMI, field bus configuration, and add-on tools to ease the application development, i.e. debugging features, interface to subversion, profiler, or static analysis. Applications developed with the IDE are then executed by the CODESYS control runtime system. It needs to be pre-installed on the controller. The RTTF is fully integrated in the CODESYS environment and allows testing any ICS that embeds the control runtime system and implements two key components, sys Ethernet and systime get microsecond. The operating system used on the device has no importance as long as these two components are implemented. On the IDE side, RTTF is a package comprising a user interface, a program, libraries, test scripts, and even integrates the Linux cyclic test should the device be based on Linux. The execution is either done manually or using the CODESYS Test Manager as automatic testing environment. The third part of the system is a specific board from Texas Instruments that will replace physical I/Os and for which a specific firmware has been written. The system allows testing the real-time performance of the ICS. The CODESYS task jitter, jitter on the Ethernet communication, and optionally, Linux thread latency. All these in different running conditions for connectivity and for typical but critical controller running conditions. The test application executed on the controller sends Ethernet frames cyclically. Each frame carries a timestamp in microseconds containing the time when this frame is sent. The network analyzer receives the frames, adds the received timestamp, and as soon as the defined amount of frames is reached, sends them back to the ICS. The specificity of the network analyzer is that it processes these frames with hard real time, so jitter-free. The ICS then collects the send and receive timestamps and calculates the maximum task jitter and slave receive jitter. The slave receive jitter, which corresponds to the ICS transmission jitter, is a key value for real-time performance of the ICS and indicates the stability of the frame transmission. The user interface allows configuration of the test parameters before execution. The number of cycles, being the number of frames sent to the network analyzer, the cycle time, maximum iteration, how often should the test be executed, the frame size in bytes, the allowed task jitter, and the allowed receive jitter that are defined by the manufacturer. The results are presented graphically. On the x-axis, we find the jitter interval in microseconds. On the y-axis, we find the amount of frames in each jitter category, represented in percentage of the total amount of frames. At test completion, the maximum transmission jitter is displayed. In this example, 2 frames out of over 100,000 had a jitter higher than 1 millisecond. A color marking indicates whether the test was passed. Now, in order to estimate the stability and performance of the Ethernet frame's reception, a round-trip test is executed. In that case, frames are again sent cyclically. Each frame carries a timestamp, which contains the exact time when it was sent. The network analyzer receives the frame and sends it back immediately. The ICS receives the frame and calculates the time between frame sent and frame received, meaning the round-trip time. For real-time systems, this round-trip time must be stable. A short round-trip time indicates a high performance of the Ethernet communication, meaning how fast the fieldbus I/O update is. This round-trip test can be activated optionally. The tests are executed under different stress conditions in order to make sure that typical running conditions do not influence the performance. The framework offers an interface for customer-specific test conditions. For controllers based on Linux, RTTF offers the possibility to run cyclic tests to test the thread latency. Here you can configure the number of test cycles, set the allowed maximum jitter, and set the specific test arguments. Hackbench allows you to stress the system and can be started in parallel to cyclic test. It's also possible to choose system-specific conditions. In that case, you can execute any Linux command and implement scripts causing special conditions in the PLC. These conditions can be called in this user interface. So now that we understand the concept behind the real-time test framework, let's have a look at the tool itself. So we have already installed the package in the CODESYS environment. So for those that are familiar with CODESYS, you'll recognize that this is the CODESYS v3 environment. And we have already installed the real-time test framework application. We have connected the test PLC. This is running. And the package comes with a set of libraries, which basically contain the scripts and how the tool works. And it also comes with a user interface that will allow us to both set the test parameters and receive the results in real time and also as a final information. So you do remember that there are two ways to use the real-time test framework. There is either the manual way, so we can manually launch the test scripts, or what we recommend is to use the CODESYS test manager. That is a lot more user-friendly. In this case, the test cases are run automatically. They are run after each other, and we will also get a complete test report in HTML. So for to explain and to show you how the RTTF works, we will do it manually in this case, but I will also show you some examples of the test reports in case of an automatic testing. So I have a device here that comes with more than one Ethernet interface. So I need to select the Ethernet interface that will send the frames to the network analyzer. So I select this interface, and then I can set the test parameters. First of all, the number of cycles. How many frames do we want to send for this demo? So I'm just gonna send a few, so it doesn't take too long. The result, basically the concept will be the same. The results may differ. The more frames and the longer you test, the better. But for this demo, we will send just 1500 frames. The cycle time is defined by the task configuration. How many times do we want to repeat this? So we'll send 3 times. So I said 3 iterations. Do we want the round-trip test to be executed, yes or no? So I would say yes, we're interested to see the round-trip test, so to see how long it takes from the moment we send the frame out of the controller. It goes through the I/O system, and then it comes back to the controller. So we want to see how long that takes. The size of the frame, so let's say we have 1 kilobyte per frame, and the allowed task jitter, the allowed transmission jitter, and the allowed round-trip time. So this has to be defined by the manufacturer. So the user needs to define for this application what are the performance that he wants to or she wants to get. So the task jitter, let's say we want maybe 100 microseconds task jitter. the transmission jitter the same, and about the round trip time. So let's say we want maximum 1.5 milliseconds for the round trip time. Okay, once this is set, we can start the test. So we see that it started, so we have the test status here. So the frames are sent, they are received, we have iteration, the first iteration, and we have automatic and real-time representation of where the jitter is. So these are the intervals, and we have always the maximum jitter for the task here and for the transmission here. So the results for this short test, it looks like this. We have a maximum jitter of 65 microseconds. So this is the test is passed because we selected that we had 100 microseconds were acceptable. The transmission jitter had a similar value of 64 microseconds, and we also here said that 100 is acceptable. And we have a round trip time of 0.5 millisecond, which is a very good result. So in that case, we are testing on a PLC that BE.services prepared for the customer. So this is based on Linux, and this is also optimized with a real-time patch, but also some further optimization for the Ethernet communication. So the results are not surprisingly good. So they are very good, but we were expecting these results. So this is basically how the real-time test framework works. Here we had, I didn't mention, but we had the test in normal conditions, so we were not stressing the system. So this is how the performance looks like. So if we do the same but using the test manager, then we will have longer testing, and we will have the results in different test or stress conditions. And this will look like this. So this is, for example, in case of network variables. So how does this perform in terms of performance when we have a network variable? So we see that it was tested at that time by this engineer. We had 21 test cases, we skipped 10. And we have a complete report of all the actions, whether they succeeded or not. And then we have the results. In this case, the task jitter, the transmission jitter, the round trip. We had a lot more iterations here. It was a bit longer. And another test report that I want to show you. This is we also run the Linux cycle test on this platform. So this is done the same way. So this is the same environment, and that allows to set the test parameters. Here the arguments for the cycle test, number of cycles, also the limit that we want to test, and then we had both Hackbench and also some system specific conditions, and then we had the task jitter. So the thread latency on the Linux system of 76 microseconds, which is, I think, also a pretty good result. So that's it for the real-time test framework introduction. So thank you very much for listening, and if you have any questions, please contact us.